Hi there! In this lesson, we'll talk about a statistical model called KNN. Machine learning is intimately related to statistics. The way a computer can learn from data is by using statistical models. The first model we are going to use will be KNN. So let me tell you a little bit about it before we get started. KNN stands for K nearest neighbors. Every time we work with this model, we will have to define a value for k to find that many nearest neighbors. Let me use a chart so it's easier to understand. Let's say we get our data from the Iris dataset and make a chart with the values of petal width and petal length. By the way, this is only an example. Those are not the actual measurements for the Iris dataset. As you can see, I'm simulating it with only two species. So here we have the measurements for the green and blue species. When we look at the chart, we can see a clear distinction of those two species. The blue species has wider and larger petals than the green species. But in the middle, there are some points mixed together. When we have the measurements of a new observation, we want the computer to predict the species. So let's say this was the new observation. We could say with a high level of confidence that it belongs to the blue species. On the other hand, if this was the new observation, we would have no doubt it belongs to the green species. But how do we classify an observation that has these measurements? It is very close to a blue point, but it's also positioned closer to the green side. We can use KNN to solve this problem. In order to do this, we will have to define a value of k. So let's say it is 1. In this case, the model will get one closest neighbor, which will make our prediction go to the blue species. If we define the value of k as 3, it will get the 3 nearest neighbors. In this case, we have 2 green points and 1 blue point. Therefore, the classification would be green. As we can see, defining the right value of k is very important because it affects the result of our classification. The good news is that we have tools that allow us to test the performance of different values of k, so we can choose the one that best suits our problem, which is the one that makes the computer have the lowest error rate. And now that we know how KNN works, let's go back to Jupyter and apply it to the Iris dataset. The first thing we need to do is import KNN. So let's type from sklearn.neighbors import k neighbors classifier. Pay attention to the capital letters, otherwise you have an error. So after doing this, let's create a new variable called KNN, and then let's run the kneighbors function. So we can just copy this name, and this is now a function, and as an argument of this function, we need to pass the value of k. So let's use n neighbors, and let's define it as 1. We don't know if 1 is the number that will bring us the most accuracy, but as I mentioned, we will see later how to pick the best value for k. Now we can just run it, and let's create two variables to store the observations and the target. Capital X is commonly used for the data, so capital X equals iris.data, and Y is commonly used for the target, so Y equals iris.target. I don't know if you got this error. It says that the name Iris is not defined. This is because I just closed Jupyter and reopened it again. So every time you reopen Jupyter, you have to run all the cells above. So we can go to Cell, Run All. So now we don't have that error anymore. Now that we have everything ready, we're going to run the fit function, which is the one used to train the computer. So knn.fit, and then we pass x and y. As you can see, this is giving us some information of what has been done. This is not very important at the moment, but you can see here the number of neighbors we passed in the beginning. So this is the value of k. So we just trained our computer with the data we have. And now we are ready to make our first classification. So let's use knn.predict. So inside the parentheses, let's be a bit careful because we need to pass a list of observations. So let's open braces. And now we're only going to pass one observation, and one observation is a list of measurements. So let's open another list here, and now we can pass some measurements. Since we don't have an actual iris flower to make this test, let's get one from our data. So let's just go up here. We know that the first 50 observations are from species 0. So let's just get this data, put it here, and now let's put commas to separate the values. So now we have one observation, and let's see if the computer can predict what is the species of this flower based on its measurements. Don't forget to include the print function. And now let's run it. So we can see that our computer classified it correctly. Let's make another test. Let's make one from the end, which we know belongs to species number 2. So let's get this one here. Let's run it again. Let's make some adjustments here and run it again. And we can see that we have the right classification again. So our computer has learned from our data, and now it is capable of identifying the species of a new iris flower based on its measurement. But there is one problem here. We used all the data to train the computer, and now we passed 2 observations that were already part of the training data, and this is not ideal. How do we know that the computer really made a classification and not just looked for those values in the dataset and the corresponding species? What would happen if we passed an observation that is not part of our dataset? Would the computer still be able to make the right classification? This is what we need to know. And since we don't have new observations of iris flowers to test our program, we will do something that will allow us to test the accuracy of our model. We're going to split the data